Alright, so kicking things off this week, we are talking about variables and operators. This is almost entirely going to be review from CS230, but there are some key differences with Python and C++ that you're going to have to be aware of, and we're going to touch on those throughout the course of this lecture. So, we're going to quickly refresh ourselves. What are variables? We're going to talk about strong versus weak typing, what that means. It's important to languages like C++ and Python, as well as others like JavaScript and Ruby. We're going to talk about data types, type modifiers. This is something that you don't really see in Python, but you do see a lot of it in C++. We're going to talk about typecasting, which is something that we did in Python. And we're going to do it less in C++, but I still want you to be aware of exactly how we go about doing it, because there are a few different methods. And then we're going to do a brief review of operators, look at the difference between those in Python and C++, because the ones in C++ exchange words for symbols and are a little bit more difficult to memorize. So, remember that a variable is a container for a single piece of data. There's a wide variety of data types. A lot of these will be very familiar to you from Python, and then there's going to be some new ones. So we have integers, which represent whole numbers. Floating point numbers represent any sort of real number. So it could be a whole number. It could be a rational number like 2.5. It could be an irrational number such as pi. You also have booleans, which are your true-false values, and strings, which represent text. And strings are a bit of a special case in C++, so we're going to take a closer look at those when we get to them. So, not only does C++ support all of these different data types, it also supports modifier terms that we're going to look at later on. And these will constrict or expand the range of values that a variable can have depending on which modifier terms are used. So, a word on strong typing. So what this means is that variables have type. Functions have type. More importantly, focused on the variables. So, in Python, it's somewhat explicitly stated because you can expressly cast something to a string or an int using that variable's constructor. On the other hand, C++, everything, when it is initially declared, must be declared using its type. So if you want to declare an integer named x, it would be int x optionally equals something. And the pros of this is generally less error-prone code, enforcing a stricter set of rules, makes things a bit easier to follow, and prevents runtime errors. On the other hand, it is inflexible, and there are difficulties in defining collections because we have to define a collection as being of a given type. And that it creates a little bit more thought, and it also constricts, in the case of C++, where collections are not a type of their own, but rather have a type. It means that that collection can only store that type. So if you declare an array of integers, you can only fill it with integers. And then we have weak or loose typing. This is a feature of languages like JavaScript, PHP, Ruby, and it's not explicitly stated what type something has. So, like in JavaScript, things are going to be defined as var or let, and these don't define its type. Rather, they define some behind-the-scenes properties of that variable. So the pros of this is it's generally faster and more flexible. However, on the flip side, weak typing is more error-prone and can generally lead to some strange behaviors with code if, say, a variable of one type is accidentally overridden with data of another type. There's nothing stopping that. So it does create some anomalous behavior. It is more error-prone, but it that's not to say that it's less useful. Both of these have their uses, and paradigms within the given language will make the best use of strong or weak typing, whichever one that language implements. So now we're going to get into the C++ data types. For the most part, they're ones that you've seen, but there are a couple of new additions, and we're going to focus on a smaller set of types. In CS230, we looked at basically everything that Python had to offer. C++, we're just going to focus on the ones that we need for this course. So, starting with the smallest and working our way up. Booleans, we know these represent true, false values. When you create a variable and you want it to be of type Boolean, you precede its name with bool. And you'll see when we do some examples that you only use the data type the first time that you declare a variable. After that, you can just reference it by name like you did in Python. So, true, false values, generally 0 equals false, and all other values are true. You can evaluate any variable as a true, false, and this is generally how it's going to work out. And by default, when you print a Boolean variable, it's not going to come back as true, false. It's going to come back as 1 or 0, respectively. You can change that, and here's the code that does that. So if you want to do cout, you precede your Boolean variable with bool alpha, and then another left shift symbol here. If you're using printf, then you would use the %s to format a string. You would say x question mark true colon false. True and false being wrapped in quotation marks. What you're doing here is saying what is the value of x here? What does this evaluate to as a true false statement? If it's true, we send back the string true. If it's false, we send back the string false. This is a sort of simplified if statement that's been broken down into like one line, one condition, very much used for the most simple of if statements. I generally don't use these, as you'll see, but I do have them here to make you aware of them. Okay, so the character. These are defined using the char or char keyword. And these store an 8-bit ASCII character, which ASCII, that is the American Standard Code for Information Interchange. And this just defines the basic set of 256 characters. It's more or less the ones that you're familiar with, your uppercase, lowercase letters, your punctuations, your numbers, other special characters, some accented characters as well. But it doesn't include things like kanji or hiragana. So for those, you're going to need a more broad set of characters using a different data type. So some examples, of course, A and accented O, or the @ symbol. Each of these characters has a numerical value, depending on whether it is signed or unsigned. We'll get to that in a moment. It's either from -127 to +127, or from 0 to 255. So here's a link where you can view the ASCII table if you're interested. Just think of it as the basic set of English language characters with some Spanish/French/German, Italian characters thrown in the mix. You know, your accented letters that are present in those languages, but not so much in English. There is also the wide character, or wchar_t. It can store a 32-bit character value, and this is where you're going to find more more characters from more languages, mathematical symbols, and so on and so forth. Strings. These are a potentially very large data type. They are defined, or declared rather, using the string keyword. Of course, it stores a piece of text in double quotes, and that's a distinction to make with C++. In Python, it didn't matter if you use single quotes or double quotes. In C++, characters are stored in single quotes, strings are stored in double quotes. So remember that distinction. We're going to show that off when we do some quick code demonstration. Some examples, of course, hello, ABC123, just any old text that's been thrown into a pair of double quotes. You can generally think of this as a collection or sequence of char variables, and you can even reference them as such using subscript notation, the bracket number bracket notation that we used in Python to reference pieces of a list. Now, here is one big distinction with strings in C++. They are not a native data type. You can't just use them straight out of the box. You have to include this line of code outside of your main function, outside of whatever body code you might have for that given file. And it is pound include. Remember, that is a preprocessor directive that tells the compiler, hey, before you do anything, retrieve this library of code for us to be, because we're going to be using it. And we say include string.h, and we do that inside angle brackets. Integers. These are exactly as they were in Python with one difference, so they're declared using the int keyword. By default, stores a 32-bit whole number value. So any whole number generally within the range of these numbers here. So that's negative 2,147,000,000, so on and so forth, to positive the same thing. Or, as an unsigned, it's from 0 to 4,294,000,000, so on and so forth. So this is the range. This is as far as a standard integer can go. If you go beyond this range, say you go with a signed int, you go above its maximum range, what will happen is it'll wrap around back to the negative range, and this is called an overflow. Conversely, if you go too far into the negatives, it'll wrap back around to the positives, and we call that underflow. And this is an error that you generally want to try to avoid. If you need more space, there is a keyword for these. We have floating point numbers. So these are declared with float, just like they would be in Python if you were to cast a number explicitly as a float. This is a 32-bit real number value. Can be positive or negative. Generally lower depth than what a lot of programs might call for. And in using floats, you'll often notice a compiler warning saying, hey, we're having to truncate the information you gave us down from a double to a float, which we'll get to a double in a moment. So these store up to 7 digits of precision, and rounding errors will happen. So truncation is when you have a certain amount and that cannot be represented within the 32-bit limit. So what will happen is you'll have some data loss. Now, to mitigate some of that data loss, what you might consider using instead is this, the double precision floating point number, or double for short. And that is the keyword we use to declare it, is double. And this is twice the precision. Instead of a 32-bit real number, it's a 64-bit real number. And this generally goes to 15 digits of precision. There are fewer issues with rounding and truncation, but they do still happen because computers have their limits. They can't represent fractional parts perfectly, especially when irrational numbers are in the mix. And then we have valueless. This is a special sort of case defined with void, or declared with void rather. And this is pretty much only used for functions and parameter lists, but you can also declare what we call a universal pointer. You don't need to worry about what that is for this course. We don't ever actually use it. So void is generally used to specify a function that either has no return value or that takes no parameters. So, some type modifiers to be aware of. There are several. For the most part, these are the ones that you need to concern yourself with. First off, we have signed. Essentially, this means that the number value of that variable can be positive or negative. So a signed integer can hold negative numbers, and by default, your integers are going to be signed. Unsigned is something you have to specify more explicitly, and it means exactly what you think. You can't have a negative sign on a number that is unsigned. It is only positives and 0. And we have short. For an integer, this is going to restrict its size to 16 bits. So that would limit its value if it's signed to negative 32,767 to positive 32,767. Long is going to increase that to 64 bits instead. So much, much wider range. You can also use long to apply to doubles, and that extends their range up to 96 bits. So then for integers, we have the long, and this explicitly states that an integer is being declared with a size of exactly 64 bits. So with a long, it could be 32, it could be 64, depends on the value. A long, we know we want it to fill that entire 64-bit range, so that's where we use our long integers. And we have const. This is what specifies a variable as, okay, we need to give it a value at the same time that we declare it, and that value can never change. It instructs the compiler, hey, don't ever change this. And if the user tries to change it, then you need to throw an error. And lastly is volatile. And this is a bit more of a special use case type of variable. So oftentimes during compilation and linking, your program is going to try to optimize certain things. If it thinks that something should be a constant, it will make it a constant. And this is not always correct because that variable might be altered by something else somewhere in the program or even something externally. And so the volatile keyword is used to prevent that issue. It tells the compiler, hey, don't try to optimize this into a constant. Leave it alone. We're gonna change it. It's just not gonna be an obvious place where it's gonna be changed. All right. Now we get into typecasting. And this is exactly what it is in Python. You're taking a variable of one value and you're throwing it into a variable of another type. So in Python, it was as easy as calling the constructor of that data type and then throwing in the variable you want. In C++, it's not quite the same, and I reiterate that we don't use it nearly as often as we do in Python, just because it's a little bit more dangerous, a little bit more going against the idea of C++. So generally speaking, there is some implicit casting going on, and this is something that's done without any of your input. And there's a range or a sequence that it'll follow to make a variable fit into a different type. And those types are generally going up. So it'll implicitly cast a bool into an int. but it won't implicitly cast an int down to a bool because you'll lose a ton of data in the process. So it only goes up in data range. Then you have more explicit casting, which is done via code. So you can either convert by assignment, where you'll say y equals int x, and either int or x must be wrapped in parentheses. Or you can convert using the casting operator, which is static underscore cast, type, which is wrapped in angle brackets, and then in parentheses you have the original value. Again, be aware of these, but I don't expect you to use them at all in this class. They're not something that you'll find yourself using very often. So we're just going to be aware of these and move forward. So now we're going to do a brief review of operators before we get into a few quick code examples. So, C++ versus Python, the big difference is going to be these double arithmetic operators here. So, if you remember in Python, the plus plus and minus minus operators, those don't exist. Those don't really do anything. But here in C++, they do, well, what we talked about in CS230. So plus plus increments by 1. It is called the incrementer. And then minus minus, conversely, is called the decrementer. And it decreases the value of a variable exactly by 1. And we have the times times, star star, or however you want to read it, operator. In Python, this is used for exponentiation. So 2 star star 3 is going to give you a value of 8. C++ does something very different with this operator. This is called the this is used to create a pointer to a variable. What's a pointer? We'll get to that way later in the course, after we start talking about classes and stuff like that. So for now, don't worry about it. Just know that this is how you create a pointer to a pointer. And then we have the slash slash divide divide operator. In Python, this was division with floor. So it was a division that produced an integer. In C++, this is how you start an inline comment. It actually does nothing for your code. And so here, this is the table from the Python slides from 230 with all the different types of operators, but with the necessary changes made. So you see your assignment slash arithmetic assignment operators, they look the same. So you have your equals, plus equals, minus equals, times equals, divide equals, and mod equals. You'll notice that the times times equals, divide divide equals, obviously those don't exist because the times times and divide divide operators do very different things in C++. In fact, the divide divide again does nothing. Arithmetic is more or less the same, just with those few missing operators. So you have your plus, minus, times, divide, and modulus. That's all you have in C++. Your comparison operators, of course, you have, these are all identical from Python. Greater than, less than, greater than or equal to, less than, equal to, not equal, and equality. You have your logical operators. These are the biggest difference. In C++, they are and the pipe symbol. And also the exclamation mark not. Because if you remember, in Python, these were just and or not. And then lastly, we have our bitwise operators. You have your bitwise and, which compares things on a digit-by-digit binary level. You have or, which does the same thing. Remember from 230 when we did propositional logic, what the and or operations did. The caret symbol or up arrow, that is your XOR. The tilde mark, that is your logical not, logical negation, or bitwise negation, I'm sorry, flips the bit. And then you have your left shift and right shift. These are also, as you've seen already, the left shift doubles as the stream output for things like cout. The right shift serves as stream input, and we'll see that in use as we go along. So, some other operators to be aware of, and I want you to focus on this table for your quiz. But these are also very important. So size of, this is going to be something that you use fairly frequently because we don't have a len function per se for things like arrays. So to get the length of an array, you would have to do size of the array divided by the size of its type. Then you have this simplified condition statement. So your condition, question mark, if true, do this, colon, if false, do that. An ampersand, I'm mentioning the ampersand and asterisk for pointers here, but don't worry about these for a while. I just want you to be aware of them. We're going to use them later on. So ampersand refers to the memory address of the operand in question. And then the asterisk is the pointer to that operand. You can also use this to access the value pointed to by a pointer. Dot operator is how we access members and methods of classes, which we'll see when we get to that point. Sometimes we're dealing with pointers to objects of a class, in which case we'll want to use the arrow operator. This does basically the same thing, but it's for referencing pointers. We have the double colon. We call that the scope resolution operator, and that explicitly specifies the scope of a variable or function. We'll see it a little bit, but not much. Just because of the way that we're going to be doing things is going to eliminate the need for this in a pretty big way. And then, again, this is your output stream, this is your input stream. So, that covers the basic material. Now what we're going to do is I'm going to jump into code blocks. I'm going to turn on magnifier so I can see what I'm doing, and we're going to make a project. And this project is just going to show these data types in use. So, create a project. I'm just going to create a console application, C++, and we're going to call this variables. Click next. This is all good, so we click finish. And here's our project. So let's open up sources, main.cpp. And we have all this here for us by default. And there's a few changes I like to make before I get going. So, first thing we need, because we're going to be working with strings, include string.h. We already have IOStream, we already have using namespace standard, so those are fine. I like to change the formatting a little bit to look more like this, where the opening brace is on the same line as the block header, whether it be a function, an if statement, or whatever. So we're going to erase this really quickly, and we're just going to make a few variables of a given type. So, pardon me, we're going to start with an int. We'll just call them single letter things because they don't really mean anything. So we'll call int a equals 32. Let's say long int, and we'll say this equals this massive number. Now let's go with an unsigned short int I should probably give this a name. Unsigned short int C. And we'll say this equals 65,000. These are all just good examples of what will fit into a specific type of integer. Obviously 32 is just a dummy value. And let's do a double D equals 3.14159. So doubles are going to be more useful for irrational numbers. Floats, on the other hand, are going to be more useful for rational numbers like 2.25. Okay. Now we're going to do a char f equals. Remember to open up single quotes. We'll say it equals at string g equals, I'll just do my name. And of course, remember to end these lines with semicolons or the compiler will yell at you. So we've got our int, long int, unsigned short int, double, float, char, string, last one, bool. We'll call this h, and we'll say this equals true. And we're going to see what happens when we just print h on its own. So here's a bunch of examples of how you can combine terms, combine modifiers, and be more specific with your variable types. Is this always necessary? No. Just consider the range that you need and work accordingly from there. So now let's just see out each of these. You could use printf. If you enjoy using printf more than see out, go ahead. I am just used to using see out. So see out, we'll say a is an integer. We'll end each of these on end line, or ENDL. So let's copy paste these. We need 8. All right, now we'll adjust these accordingly. B is a long integer. C is an unsigned short integer. D is a double. E is a float. This is very mundane, but I'm doing this just so we can see it on screen. F, that is a character. G is a string. And H is a Boolean. And we save this. Very simple. We're going to hit F9 to run it. And then we see something has gone wrong with this long here. It has been condensed to this. Let me try something. Whoops. Sometimes when you close the command line for your code blocks project, it'll throw you into another window. Let's call this a long, and try again. There we go. So, we see 32, that's just a standard integer. 99 billion yada 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 is a long integer. a long integer. 65,000, that is an unsigned short. An unsigned short is going to have a range from 0 to 65,536, or 65,535 rather. 3.14159, that's a double. 2.25 is a float. At is a character. My name is a string. And then 1 is a Boolean. This is what I really wanted to call attention to. Like I said, when you print a Boolean on its own, it's going to come out as a 1 or a 0. If we want to fix that, we come down here and we say bool alpha, and then another output stream. I'll run it again. True is a Boolean. There we go. And I'm not going to run through operators again, as they are more or less the same. Just practice getting used to the fact that your and, or, and not operators are going to be the double ampersand, the double pipe symbol, and the exclamation mark. We're going to get a lot of practice with those, so just bear those in mind. Those are the only differences that you really need to be aware of, apart from the inclusions and exclusions versus Python. So I really wanted the focus of this lecture to be on data types, and here we are. Generally speaking, char, string, int, bool, float, and double are going to be the only data types you need. If something else comes up, then we'll discuss it. But that's going to do for this lecture. I know this is a bit off the cuff, a little bit unpracticed. The snowstorm that's going on up north had this knock-on effect down here. We ended up having to cancel due to the freezing rain and the bitter cold. But I hope this helps you get through all the material. And then, of course, we're going to come back on Thursday and have our quiz. So if you have any questions, you know how to reach me. Otherwise, take care.